Hi everyone, this is Becky, and in this video we are going to take a look at what percent yield is and how to use it. Okay, so our goals for the video are to understand what percent yield is and why the yield of a reaction is typically less than 100%, and then to be able to calculate percent yield as part of our stoichiometry problems. Okay, so let's say that I carry out the reaction that is below, and you might recognize this as the question at the end of the limiting reagent stoichiometry video, where I'm mixing together iron and sulfur and getting iron sulfide, and I reacted 4.68 grams of iron and 2.88 grams of sulfur. So in class we went through this stoichiometry and we found that in theory I can produce 7.37 grams of iron sulfide. So that's if the reaction proceeds perfectly, I'm able to isolate everything that I make. That is what I get. And this number here, what the stoichiometry says, is called the theoretical yield. So in theory, that's how much I could make. Okay, cool. However, when I carry out the reaction, instead of isolating 7.37 grams of iron sulfide, I actually am only able to isolate 6.72 grams. Okay, and this number that I'm isolating, this is called the actual yield. Now, a couple of things. Actual yields are typically way less, or not way less, but are typically less than 100%. Because if you think about it, like just in terms of the practicality of mixing things and isolating things, I always lose something along the way. Like, for example, if I'm making a solid and I have to filter it, right? When I pour it into the filter, I'm going to leave some behind in the container that I made the solid in, and so I'm going to lose some there. So theoretical or actual yields are typically less than theoretical yields. And we got to account for that in our math. Okay, so if I was able to, in theory, make 7.37 grams of iron sulfide, and I actually only made 6.72 grams of iron sulfide, in order to calculate the percent yield, which is how much of the theoretical yield I was able to isolate, what I'm going to do is I'm going to take the actual yield, I'm going to divide it by the theoretical yield, and then I'm just going to multiply that by 100. So in this case, right, my actual yield is 6.72 grams of FeS. My theoretical yield is 7.37 grams of FeS. So I'm going to do that math, and I'm going to multiply that by 100 to get it into a percentage. And I get 91.2%. So for this reaction, my percent yield was 91.2%. Okay, pretty straightforward. A couple of things to keep in mind. Actual yields need to be given to you in the problem. There's no way to calculate them based on like the masses of reactants or anything like that. They have to be given to you. And typically they're going to be less than the theoretical yield. Sometimes they're more, and we'll talk about why that is in the lab next week. Shh, spoilers. Okay, so let's put this in practice. I'm looking for the percent yield for the reaction between 3.74 grams of sodium metal and excess oxygen if 4.34 grams of sodium oxide are collected at the end. So here, again, I'm looking for the percent yield. First thing I need to do is to calculate the theoretical yield. So the first thing that I need from that is a balanced equation, right? So I'm reacting sodium metal plus oxygen gas, and I'm producing sodium oxide, which is Na2O, oxygen minus 2 charge, sodium plus 1, so Na2O. Balancing the equation, I need a 2 in front of the Na2O, and then I need a 4 in front of the Na, and then we're good. It's balanced. Okay. I know that I'm reacting it with excess oxygen, which means that I only need to do the stoichiometry once with the 3.74 grams of sodium. So 3.74 grams of sodium, and then I can change that to moles of sodium. It's 22.99 grams of sodium. And then I know that I get 2 moles of sodium oxide for every 4 moles of sodium. And then I can turn that back into grams by multiplying it by the molar mass, which is 61.98 grams of Na2O per 1 mole of Na2O. Okay. And then I put that in my calculator, and I find that I can produce, in theory, 5.04 grams of Na2O. And that's my theoretical yield. So in theory, I could make 5.04 grams of Na2O. In practice, I only make 4.34 grams. So now I have to calculate the yield, the percent yield. So the percent yield is actual over theoretical times 100. So in this case, it's going to be 4.34 grams of Na2O over 5.04 grams of Na2O times 100. And I put that in my calculator, and I get 86.8%. So the yield of this reaction is 86.8%. Okay, cool. All right, so your turn. Let's try this one. It's a question at the end of the video. So try it, bring it with you to class on Monday or Tuesday. I want you to determine the percent yield for the reaction between, if I take 46.5 grams of zinc sulfide and I react it with 13.3 grams of oxygen, and at the end I isolate 18.4 grams of zinc oxide, and I produce an unknown amount of SO2. So my goal is to calculate the percent yield. Think about the steps required to do that, give it a try, and we'll see you next time.